So I am recording this webinar. When I'm done, about an hour after the webinar, you should be getting an email with the webinar. So that way you can have this to use to review, or just to go back. If there's something that you remember me saying, you can go, oh yeah, I remember Ben said something about that, and you can go back and look at the webinar. So with that, if I push the button correctly to get started here, what we're going to be talking about first is we're going to talk about the faults. So what the monitor's main job is to make sure that the intersection is running correctly. One of the things to do is you want to make sure you program the monitor correctly to monitor the intersection. But what I'm going to do first is go over the faults because I always like to, a lot of times people's first introduction to the control or the monitor is when it has a problem. So in the TS2 cabinet, one of the big problems that you'll come up with is the port 1 fault. And what that is that's in a TS2 cabinet, you have a communication bus, which is called the SDLC, and you want to make sure that's plugged in and working. So on the monitor, if you ever get this fault, port fault, what you're going to do is you're going to look at all your connectors with your SDLC. The first thing I always do is look at the monitor, make sure that the TAT and receive lights are flashing, and they should flash. If they're not, that would tell you that the connector is either not connected correctly, or the connector, the wire itself might be bad, or the connector might be bad. If you check on the monitor, that one's working. You check on your controller, that one's flashing. Then you want to start looking at your BIUs, and you have your 3 BIUs. You would have one in your detect rack, and then you usually have 1 or 2 in your load rack where you'd see your load switches. So that's the BIU, and you want to make sure they're all flashing. If they're not, you're going to get this port fail. The second common fault is a conflict. When you get a conflict, that usually tells you that you have 2 phases that are on simultaneously that weren't supposed to be on. So when you program your program card, you tell the intersections what is permitted and what isn't. So if you get a conflict that you don't expect to get, you might want to check to make sure you've programmed your program card correctly. If you haven't, you want to make sure you take that and fix that problem. One of the things I want to show you is our monitor has a unique diagnostic tool that will help you, which is a diagnostic wizard. And what that does, it helps you find out what the problem is and how to fix the problem. So a lot of times when you come up to an intersection that's in fault, the first thing I always tell people is try to take mental pictures, but now that you have cameras on your phones, I always like to take pictures of the intersections, because sometimes you'll come up to the intersection and the first thing you want to do is to try to get the intersection up and running. What you really need to do is make sure you capture all of the information before you start pushing the reset button. The first thing you want to do is look to see what's going on in the cabinet and in your environment around the intersection. Then you hit the help screen, and there's a help button. With the help button, it will tell you what's going on. So in this case, I'm going to run through. When you come up to the intersection, it comes up, and in this case, we have an intersection in fault. It's got a conflict. So this is the screen that you actually display. I always say the main screen is what we have to display by NEMA spec. The second button, when you push it, or the first time you push it, it tells you, I always like to say in English, or tries to explain what the problem is. And in this case, it's telling you that there's a green or yellow signal that's active that's not really supposed to be active. You push the button again, and on this drawing, it doesn't show, but usually if there's more information, there's an arrow in the lower right, meaning push the help button again, and it'll give you another screen. So in this case, I'm going to push the help button. And now it's telling you, and I always say in this case, it says the second screen, but I always say it's a third, because the first one is the one that is displayed. It tries to tell you what's going on. And in this case, it's telling you that phase 7 yellow should not have been on. So at that point, you're going, okay, my problem is phase 7. So don't worry about 2, 6, 13, or 15. you should go to 7 to fix the problem. So that's where you would go to get and fix your problem. The last one that you see here is going to give you suggestions. And I want to really point this out, because if you have your TS2 cabinet set up and you set up your field checks correctly, what this you may get in this case, it says it's a load switch, field short, or an open loop or load switch. If there's a controller issue, you'll get a completely different screen. It'll say check CMU, and then it'll try to talk about that. So when you get to this third screen, or the wizard, the last wizard, to try to help you troubleshoot, don't just assume that it's going to be the load switch, flash, or BIU, any of that. This usually gives you a heads up of what the monitor thinks the problem is. So if it thinks it's a load switch, that's the first thing you might want to start looking at. Doesn't mean that it's going to be the problem, but the monitor is going to try to point you in the correct direction, as I want to say, as quick as possible. The goal of the wizard is to help you fix the problem in a timely manner, so you're not out there for 2 or 3 hours. So with that, we're going to go through some more of the faults that the monitor will throw, and on the menu, like this next one I'll show you, I will try to show you what a typical menu might show up. So red fell. A lot of people, when they see red fell, especially if someone that's new or a novice, they think when you see a red fell, there's a problem with the red. Most of the times it isn't. And most of the times when you get a red fell, you know it's going to be a problem in the cabinet. So let me explain to you how red fell came about. The history of red fell is back in the old days when signals were first activated. You would have a four-leg approach that has red all around. A car would come up, it would service it by giving it a green, then it would go yellow and back to red. And usually it would rest in red. But over time, they started to try to major minors and major majors, they're trying to reduce delay, so they would have one phase or one direction or multiple directions green, and it would only activate when there was a side street. The reason why I bring all of this up is back in the day, you would come up and you see the intersections in red. I expect it to go to green, and when it goes from red to green, if there was a bad head or a illuminate or one of the bulbs were out, the intersection would go on the flash. So when that would happen, it got the habit of people saying, well, that's a red fell. So what a red fell really is lack of signal. So that means that signal on one approach was supposed to have a red, yellow, or green, and now it doesn't. So a red fell is just telling you a lack of signal. The reason why I tell people when you see the red fell is going to be in the cabinet is because when there's a problem with a red fell, it's going to be the cabinet, because that's the first thing that the monitor's looking for is components in the cabinet. So usually when you get a red fell, it's going to be either a controller or a load switch in the cabinet. If there's a problem in the field, i.e. light bulbs or LED heads out, you're usually going to see either a dual indication or a conflict. So when you get a red fell, expect that you're going to have a problem in the cabinet. And here, if you notice, it tells you that channel 5 has no indication, as it says, no signal colors are active on this channel. And then the next one, the third screen, tells you, hey, check load switch, check CU, which is controller unit. And then it tells you to go out and look at the field. But usually here it's telling you really the field load is the terminal bus in the cabinet or in that area. So I always like to tell people, especially new people, that if you got a red fell, odds are it's going to be in the cabinet. Now, I've been doing this for 40 years. I can count on one hand how many times I had a red fell that come to find out it was a field issue. Here's where you would see a field issue when you get dual indication. So usually what happens is when you have no indication, or you lose all of your LED heads or your incandescent bulbs, you would get a on. So usually you would see something like this. Let's say the red is out in the field, so you're going to get a dual indication showing that this is going to be on when the green comes on. And if you notice here in the dual indication, it's telling you that it's either green, yellow, yellow, red, walk yellow, walk red, or all three are on. And there might even be four, because not only can you get green, yellow, red, but you can get green, yellow, red, walk. So it takes about a half a second before the monitor picks this up. So a lot of times people say, well, it was green in my direction. Well, the monitor will usually pick it up before the human eye can even see it. So when people say that, it's unusual for a human to actually see a dual indication in the field. It can happen, but usually the monitor will pick it up pretty quick. And usually when you get a dual indication, the first thing you want to start doing is looking at your load switches, usually the red, because you have a bulb, multiple bulbs out in an approach. Clearance fail is when we want to make sure that you have at least 3 seconds of yellow. So it should go green, yellow, red, and it should be yellow for 3 seconds. We trip at 2.7 seconds. So if you ever come up to a monitor and it says that it has a clearance fail, I'm going to tell you there's a problem with usually the controller. Most of the times I see clearance fails, or when you set up your preemption, you don't give enough time for a clearance. So giving an example of that is you have a preemption on a side street. So you have the main green, and then it goes yellow, red, goes to the side street with a green, and then all of a sudden you have a fire truck come down on the main drag. And then the way that you have your program on your preemption is, okay, I see I have a problem on the main, so I want to get back to the green on main. So it will try to shorten you want to get to the main street faster. You want to make sure that you have at least 3 seconds of yellow. And even then you might want to make sure on your controller that I always like to put a 5-second default on the side street, or just on all approaches. So at least if it goes from red to green, that it stays green for at least 5 seconds, and then it yields and gets back to the main street. The reason why I say that is that if you don't have that, sometimes the controller will automatically just say, well, I'm going to get back to the main street, and you'll have a clearance issue. It could be either a short yellow or a clearance. So you want to keep an eye on that. So if you ever get this failure, most of the times I've seen this with preemption, but it does go with the controller too. One of the other things that I like to point out is with the controller, if the internal clock of the controller is running fast, you will see the same issue where the monitor will trip and say that there's a short yellow, but when you look at the controller, it says it's 3 or 4 seconds. What you might want to do is make sure that when you watch the controller time to see if it seems to be running fast. So usually if it's running fast, it's either the internal clock may be bad, or that the power, the 600 millihertz power that you get from your power source isn't good. And on our monitor, you can actually check to see what the input voltage to the cabinet is, and also the hertz that is generated by that sine wave. And I'll talk about that in a little bit too. 24 volts, what the monitor does, it monitors all voltages in the cabinet. So I always tell people that's including the 24 volt monitor and also the CVM, or the voltage on the controller. Now on a TS1 cabinet, all the DC power is coming from the controller itself. So usually if you get a 24 volt or a CVM in a TS1 cabinet, you got to realize that the power is generated by the controller. In a TS2 cabinet, you actually have an external power supply of 24 volts. You want to check that. So the monitor is just pretty much telling you here that the power for the 24 volts is under 18 volts, and you should replace it. Diagnostic fail. This is one that I always tell people it's important. If you get this, it's telling you the monitor's saying that there's something wrong internal to the monitor. So it could be the watchdog of the monitor, meaning that we watch stuff inside our unit itself. It could be the RAM, ROM, and EEPROM of the unit. So the memory could be bad in the unit. Internal power supply could be bad, or there's other components that may be failing. I've had people say, well, I've gone out to the intersection, seen this, hit the reset, and it runs. I always say it's sort of like the monitor is sort of like your kid. I don't want to go to school. I don't feel good. And then you say, well, you're going to go to school anyway. And then you send them to school, and then they call you and say, hey, your kid is really sick. You need to come get them. In this case, if you ever do get the diagnostic fault light on, and I recommend that you replace the monitor and then either test it yourself, but I ask that you send it back to us, the manufacturer, so we can run through the diagnostics to bless it and say, and recertify it and say everything is good. The reason why I put this in with the program card is because the program card is also classified memory, meaning that the program card has to be not only programmed, you want to make sure it's programmed correctly, but you want to make sure it's plugged in and seated. So if you plug in your program card and it's ajar, or you make a change to the program, you're going to see the diagnostic light up and say, hey, something has changed. You got to push and hold the reset. And if you get this where it says diagnostic on your display, that's telling you there's a problem. If you just get the light here and you get a program card, it's telling you that, okay, program card is part of the memory. So you want to make sure that if you see just a program card, you hit reset and it goes away, and this display is like usually the only time I ever see is the program card, you know that it wasn't really a diagnostic issue in the cabinet itself. It was because the program card is part of the memory and something happened with that. It wasn't either seated, or when you pushed it in, it recalibrated and became working once again. One of the things I always like to point out too is if you ever see something on the screen and you don't know what it is, so in this case it's a program card ajar, if you hit the help button, it'll try to tell you in English, it'll translate whatever is on here on this. So when you hit the help, in this case it tells you, hey, the program card must be installed at all times. So it's telling you either the program card's not in or it's not in all the way. So anytime you get something on your display that you don't understand or you're confused with, you can always hit the help button and it will tell you what's going on, or at least attempt to tell you what's going on. Recurring pulse detect. So what this is, back in the old days, some of the older guys will know that this is when a intersection, the head is flashing, and usually with that it was called blink, dim, blink, dim. Oh my goodness, I can't remember. It'll come to, anyway, what that's telling you is that the output of the LED or the incandescent bulb is doing something not standard. Instead of being illuminated fully or off, it's blinking, flickering, or doing something different. I always like to tell people, in this point, you really need to make sure that when we send you the monitor, and I'll show you, I think maybe in the next screen, you want to make sure you turn on the LED guard, because what the LED guard does is it looks at the outputs and knows that the outputs are a LED. So in an LED head, you have a power supply and an LED. So when there's a problem, the monitor knows that there's certain characteristics or issues that the LED head can do, and the monitor, if that's on, will tell you that. So if you have LEDs, which I'm pretty sure most people, that's all they're using now, is that you want to make sure that you have LED guard on. And what I want to do is, let's see, hold on, I'm going to find it. Program card, LED guard. Here we go. So on the LED guard, what you want to do is go through, and from the main menu, you hit menu, then you're going to go Set View Config. Then you want to go to Unit Options, and then you would go to where hit Next until you get to where you see LED guard, and you want to turn that on. Okay. So the other thing that I forgot to mention is I will be sending you this slideshow. I will also send you some other documentations just so you guys have some more information. And what I want to do is go back here, over here. Let's see. Did I, 1 second. What I want to do, guys, is because I didn't realize I grabbed the wrong presentation. What I want to do is open up another presentation that shows you how to program the monitor, because I believe that's what we just went through really quick was more of, and I see there was no questions. If there's any questions at any time, I believe there's a little hand, raise your hand, and I'm not sure how I'm always on this side of the presentation, so I don't know. There's a opportunity. If you have a question, you can raise your hand. What I'm going to do is set up the unmute. So if you want to, you can unmute your screen and say, hey, I have a question. So scream, oh, I see that Mark just actually raised his hand. So you got a question?
I do. Can you hear me?
Yes, I can. And I'm hoping everybody else can hear you. So go ahead.
Yeah. Will the LED guard, and so a failure in the field, will that put the signal in flash?
Yes. So and what an LED guard is, and I want to make sure you guys understand, is pretty much telling you that the LED is either burnt out or there's a problem, meaning that there's a problem for the driver. So you do want that to go on the flash because either the head's not doing, indicating or showing the drivers what's going on. And on the monitor, it doesn't say LED guard, it'll say conflict. So what the LED guard, when you turn on the LED guard to the monitor, you're telling the monitor that that is not an incandescent bulb, that it's a LED head. Why is that important? Because for a monitor, an incandescent bulb has 3 states: on, off, blink, flicker, or noise. Okay. For an LED, you can have a myriad of issues because when the load switch activates the energy to turn on the LED head, it's turning on a power supply that turns on the LEDs. So when the monitor knows that, it knows that if it sees certain characteristics on the line when it's monitoring, it's going to say, how do I put this? The monitor is smarter when it knows there's an LED because there's other things besides the 3 stages that a incandescent bulb gives. Does that make sense? So when we first started, the monitor only had, as I said, to look at light bulbs and the load switch. Now it's got to look at light bulbs, load switch, and the power supply of the LED head. So does that make sense?
Is that a factory on? Is it factory defaulted on when you get an MMU brand new?
No, it isn't. And the reason why it isn't, and that's a good question, is we're required, a safety monitor is required to meet all NEMA specs. LED guard is not a spec, it is not even a recommendation, it's an enhancement. So what you're doing is you're enhancing the monitor. We recommend, the manufacturer, we really recommend that you turn that on, but we don't set that as a default because it's not a part of the spec. Does that make sense?
It does. And I guess I would just like to say maybe it's an agency decision. Like I know I'm going to talk that over with our traffic engineer to see, because we have multiple heads that service each phase. So to have it in flash, I get the value of that, but it makes it an emergency situation rather than how it's handled in the past. Here is we get a call saying, hey, you got a red out or you got a green out, which is just as dangerous. So we'll have the discussion with our traffic engineer practice.
Right, and I want to make sure you understand too. So let's say you have an approach and you have 4 heads on that approach or 2 heads on that approach, and one indication goes bad. The monitor will not go into flash. It will go into flash when all of them are bad. So give you an
Wow.
example, if you have one head that is so catastrophically bad that it puts the intersection at in a unsafe environment, that's what it's doing. So really the LED head isn't saying, okay, this LED is on, this LED is on, and this, it's more of, it's a catastrophic issue. So it isn't looking at just one of three heads, it's looking at that overall head. So give you an example, if one of the three heads is dark and the other two are good, it won't go in the flash.
All right, that's better. Yeah, I
Mhm.
mean, that more explains it to where we want it now.
Right. Well, and I
Because,
want to make sure I don't over explain it, because the LED guard is just giving the monitor information. And that's what I always like to tell people. The more information you give the monitor, the better it's going to be. So it's really important that if you have LEDs, you tell the monitor you have LEDs. Another good example that I like to say is, if you don't have a phase one, don't activate phase one. The monitor doesn't need to know that phase one is empty, or it does need to know that it's empty, but you don't need to be watching it. So a lot of people say, well, what I do is I grab the monitor, hit default, which is usually well, it is set up for an 8-phase intersection. And they said, well, I'm just going to stick this 8-phase monitor out at a 2-phase intersection. It'll work and it's going to run, but I'm going to tell you, the monitor is going to be looking at stuff that it doesn't need to look at, like phase one. If you have let's say a basic 4-phase intersection, north, south, east, west, you have 2, 4, 6, 8. That means 1, 3, 5, and 7 aren't even wired up. So why is the monitor looking at an input that doesn't even exist in the field? So the way that I like to say the LED guard is pretty much the same thing. You're just telling the monitor that in the field you have LEDs. So it just lets the monitor know that there's some things that the LED can do that's unusual, different than what an incandescent bulb can do. Did that make
excellent. Yeah, we definitely 100% agree with that
okay?
analogy.
So good. No, I just want to make sure you guys understand, and that was a great question. Now what we did was we talked more about the faults. What I want to do now is talk about how to set up the monitor. And that's what's really important, because the monitor can only detect what it knows. So it's important that you set the monitor up in the procedure that you understand that, okay, yeah, it's looking for that. So if there is no phase one, like I like to say, if there's no phase one, then why look at it? So the monitor's main thing is the three things it does: it detects, displays, and diagnoses. So what our monitor is going to try to tell you is, in the detect, it's going to look for things that are bad. So in this case, having one indication out on an approach that has a four signal ahead going northbound, if one LED is out, it's not going to put the intersection in the flash. It's looking for something that's unsafe. So you need to make sure you set up everything that the monitor should be looking for. So one of the things that the monitor is technically supposed to do is tell you what we call monitor speak, meaning that the first screen that I was talking about on that default that we we're talking about is what we're required to tell you. What with the help button, if you push that, we try to make it so we translate that into normal. So anyone can actually come up to the monitor and look at it and say, oh, that's a peg, caw, moo. What the heck is that? Well, if you hit the next button, it says program car in a jar. So it's important that what we've tried to done in the monitor is to try to make it so pretty much a novice or a new employee can understand what the problems may be. One of the things that a lot of people don't even know is that our monitor has a built-in voltmeter. So if you ever want to look at the field voltages of the channel 1, you would hit status on the main menu, and then it will show you that it's going to be phase 1. If you hit next, it'll be phase or channel 2, channel 3, channel 4. It'll go through all the channels. So what that gives you is, in this case, you see that it's red, yellow, green. It tells you what the voltage input is at that time. So if you see a signal that has red, you should see 120 volts. This is also where you can see if you have any problems with your load switch. because you're going to see leakage voltage. So a lot of times what you'll see is it'll say 120 volts for red, and then on yellow and green, you would get 3 to 10 volts. The reason why I like to bring this up too is during your PMs, I always like to go through and look at my my input voltages, or my output voltages from all my load switches, because if I start seeing a load switch that's tinkering with the voltage in the high teens, like 13, 14, 15, that gives me an idea that the leakage voltage on the load switch is starting to get old. And over time, it will get to the point where the monitor will start thinking that the light bulb is on, but it really isn't. But the monitor sees that the voltages are like 25, 30 volts. So it's a nice way of going through and just checking to make sure what your load, the status of your load switch. The other reason why I bring this up is I've seen it where someone looks at it and they say they get a 13 or 14 on here, and they say, well, I'm going to replace the load switch. They pull the load switch, plug it back in, and they're still getting the 13 volts. Well, the other thing that this is looking at is the output or the bulbs. So I've seen leakage voltage over an LED head too. So if you see that where you replace the load switch and it doesn't change, then you need to start looking at the 2 to 3 heads that are out in the field to see if there's a problem with that. If you push the button twice for status, the second time you push it, it will give you the voltage of the cabinet. So when I was talking about earlier, if you had a controller that seems to be running, the time's running fast, look at this frequency. It should be 60 hertz. Lately, I've seen that, and I can't find any more. Technician actually sent me a picture where it said 35. This should not be any 5 hertz either way. So 65, 55, that's where you should see it. 99% of the time is going to stay at 60. But if you start seeing something other than 60, you got to start thinking there's something wrong with your service. And what I mean by that, remember, this is connected coming from the cabinet. So depending on how you wire your intersection, some people have a power supply or a backup battery setup or backup power that, depending on where the monitor is on that chain, meaning service, backup, cabinet power, you might be seeing something from the backup power too. So I just always like to bring that to your attention. And then my favorite is the little temperature thing here. It's nice. This is the temperature that the monitor is seeing. So it's the temperature that's in the cabinet, in the monitor. And I always tell people it could be 3 to 5 degrees up or down from what the ambient temperature is outside the cabinet. And I say that with a grain of salt because I know up north in Canada and all that they'll get in the sub-zero range. Usually the cabinet will stay somewhat warm. But then again, I'm going to tell you, it gets down pretty cold. Diagnostic, that's what we're talking about, the fault. And here as I said, when it goes into fault, it gives you what I call the monitor speak. What we've done is we've actually created it where you can use a help command to help you figure out what the problem is and to understand what the problem is. It gives you clues on how to fix the monitor too, or not the monitor, the intersection. As I tell people, very seldom is the monitor the problem. It just likes to point at all the problems. So it's the guy that likes to point at the people that have the issues. So what we've done is we talked about this is interesting. I'm sorry, I want to look at something. Yes. Okay. So what we're talking about is the wizard, and this is what I wanted to get to. This is the setup wizard that we're going to be talking about now. We talked about the diagnostic wizard, and remind me what I'm going to be doing for you guys is I'm going to be setting some documents that I like to show. Well, let's talk about the documents. Let me grab one for you. I'm going to show you on the screen. So one of the documents that you'll be getting is what I call the tree. And what the tree does is it talks about, have you ever come up to the monitor and say, I want to check something or do something, and you're trying to figure out, okay, how do I get to it? Or how do I find the, let me see, hold on for 1 second, here it is. How do I change the time? So if you're in a TS1 cabinet, you go, okay, how do I change the time on monitor? If you're in a TS2 cabinet, the monitor gets its time from the controller. So if you ever have a problem with the time in a cabinet and it's a TS2 cabinet, that's going to always be the controller that's going to do that. So if you go and try to change it on the monitor, it ain't going to do anything. So this, come on, is a document that I'll send you. And this is just what I call the menu tree. So if you notice, you have main menu and it says status and menu. And then it just goes through and say, okay, if you push view, this is the next thing you get. If you push setup view, you get this. So I will send you this. This is a nice thing to have because occasionally you'll go, well, geez, I want to just know how to get to dual indication or how to set up the dual indication. So this is where you can say, okay, there's my dual indication. So I got to go here, go to setup view menu. So it sort of gives you a high-end view of the menu if you want to get back down to that. I like to show this and give you this flexibility so you can see it, but really this is only when you're not sure what's going on. With the setup wizard, if you do the setup wizard, it's going to take care of a lot of things for you. So the only thing you really need to deal with is putting the monitor in the unit, wiring it to the cabinet, and programming your program card. The dual indication, the red fails, and some of the other things, the wizard will take care of for you. So with that, I'm going to run through the setup wizard. And as I said, what the setup wizard doesn't take care of is the program card and also the user setup. And that's the menu that says the name of the intersection, some of the IP address, stuff like that, that you would have to put in. The setup wizard won't do that. So with the setup wizard, what you would do is you would go to the menu and come up and say setup wizard. Then the first thing it'll ask you is tell me what unused channels are you using. So in this case is you want to turn on by going select. It's a toggle. So you go select on, select off. So it toggles it off and on. And you want to move the mouse or the cursor across until you get to the channels that you're not using. So in this case, we're going to talk about a basic 8-phase intersection, and that channels 13, 14, 15, and 16 are overlaps or flashing yellow arrows we're not using. So we're going to be using channels 1 through 12. And we're going to say that these are unused. So once you get to there, you hit next, and then it asks you, do you monitor don't walk? Like Mark says, this is a agency policy. So this is one of those that you need to tell management or ask management, do we monitor the don't walks? If you do, you say yes. If you don't manage them, you say no. So this is something that you as a group would say, this is our policy, this is what we do. So this should be a policy answer. So most agents, some agencies, as I said, it's hit and miss. Some say yes, some say no. In this case, we're going to say yes, meaning that if there's something wrong with the don't walk, we're going to put it into flash. The next thing it's going to ask you is, where is my PEDs? In this case, the PEDs are on 9, 10, and 11, and 12. So we're going to go down and point at this and turn those on. Once we finish there, we hit next, and then it's going to ask you about protected permissives. So in this case, phase 1 and phase 5 are protected permissive, meaning that they do not have a red arrow, also known as a doghouse. So that means that this intersection, the 1 and 5, do not have a red arrow. And usually that would be meaning that it's a 5-segment head. It's a red, yellow, green, yellow arrow, red arrow. I'm sorry, yellow arrow, green arrow. So that's what this is telling. So we're telling you that it's a protected permissive movement. Now we're almost done, because then after you say next from this, when you hit, I'm going to go back here. When you hit next, it's now going to give you the review, telling you this is what you told the intersection. The monitor believes that this intersection is an 8-phase intersection, that phases 3 and 7 are protected left turns, meaning a red arrow, yellow arrow, green arrow, that phase 1 and 5 are protected permissive, meaning 5-segment head, and channels 2, 4, 6, 8 are all red, yellow, greens. The PEDs are 9, 10, 11, and 12, and they're red and walk on those phases. Once you see this, if this is correct and everything's good, you hit next set. If you have a problem, it'll say edit or go edit or clear. So if you want to, if you find that you have a problem here, edit or clear, and it'll take you back to the beginning. So if you ever have a problem, you want to make sure you can go back to the beginning. One of the other things I did not mention that I should have at the beginning is when I start to program a new monitor, the first thing I do is I assume that the monitor has something on it. So I make sure I power and energize the monitor, go to menu, set view, and move down to I see where it says set default. And I will set the factory default. I usually like to do my factory default and then I do my wizard. Okay. The other thing is, and I forgot to ask Mark, you guys do flashing yellow arrows? Yes? No? Maybe?
Yes.
Okay, cool. Flashing yellow arrows, when you are setting up a new intersection, if it's a flashing yellow arrow intersection, do the flashing yellow arrow first, then, or I'm sorry, tell the monitor that the unit it has a flashing yellow arrow, tell it its mode and all that, then do the wizard. It's very important that you do the flashing yellow arrow wizard first before you do the setup wizard. Because what that does is it tells the intersection or the monitor that there's going to be pairings, like channel 1's going with 9 yellow, or channel 1's going with 13 green. Is there any question there?
Yeah, so then there's 2 setup wizards. If there's no flashing yellow arrows, you can just do the basic setup wizard.
Correct.
Okay. So do the flashing yellow one first.
And I'm really I always like to make sure the first thing you do when you get to an intersection, it's a flashing yellow arrow. I want you to realize, okay, I got to tell the monitor it's flashing yellow arrow. The reason why I say that is when you go through this wizard, if you told the monitor it's a flashing yellow and I highlight over like channel 1, it'll say FYA channel 1's paired with 13. It'll tell you that, oh yeah, I know that 1 and 13 go together, or 1 and 9. So depending on what mode you choose, the wizard will go ahead and make sure to take care of the field check, the red fill, the dual indication, and the minimum yellow-red clearance. So if you do all of this, these are four menus you don't have to look at. So for those guys back in the day that had the old dip switches, what they would do is they look at the dip switch and just match up the dip switches. What we've done is we've done the setup wizard to do pretty much the same thing. So instead of going in there and matching your dip switches, you're just answering those 5 simple questions. If you do all of that, you're good, meaning that you're ready to go. The only thing you have to do is your program card. And you want to go in there and make sure that your program card is good. What the field check does is in a TS2 cabinet is telling the monitor and the controller to put them on the same page. So the field check is saying, okay, this is what the monitor thinks is going on, and it should match what the controller thinks is going on. So if you ever get a field check fault or whatever, it's that those 2 things aren't talking. Why is that somewhat important? Is that also helps you in the back end for troubleshooting. So if the monitor and the controller are on the same page, and let's say the monitor sends a command to the intersection and the monitor goes, oh, wait, that's not right. That's unsafe. I'm putting in the flash. So when you go through the help command, it'll say the problem was the controller. It won't tell you it's a load. Well, it's always going to say controller. If it's a controller issue, it'll say controller issue first, and then it'll say load switch flash, or gives you the monitor will give you selections. But usually, if the field check is correctly set up, the monitor will tell you, okay, yeah, the problem is the controller. So don't sit there and spend 2 hours messing with something in the cabinet. It tries to tell you to look at the controller first, and once you know the controller is good, then it might be the load switch or something else, or a field problem. So the field check is pretty much just giving you a handshake between As I always say, it's sort of like a TS2 cabinet. It's like a good family, the Brady Bunch. Mom and dad are talking, controller, monitor talking, and then all the other stuff are the kids. In a TS1 cabinet, the mom and dad aren't talking, or no one's talking, and the monitor's just looking, overseeing everything. So it doesn't know what the controller is doing. But in a TS2 cabinet, it does. And then we talked about the faults, so we already went through all of these. That's why I was saying, right now, this is a good time to ask if anyone has any questions. And you can raise your hand or submit them by, chat. Pete has a question, it looks like. Let me do this. I'm going to unmute you, I hope. There we go. So, Pete, do you have a question? Says that you're unmuted, but it doesn't look like I'm hearing you. I don't know if anybody else can hear you. Oh, there it is. Is there a way data setting? Yes. So you're asking if you can transmit the information that we just did to your program card. Excellent question. What that is we do have a, let me get back here. You will see here, we have where you can transmit, let me get it here, program card memory. All right, so if you want, the program card has a memory chip on it, and the Eberly manual or monitor, it's something you turn on. Our Reno monitor that we also sell has it, it's on all the time. So if you want to go ahead and do your setup wizard, and you want that information to be transferred to your program card, you can do that. And the way to do that is run the wizard, get it ready to go, and then you want to go and turn on the program card memory. And the way to do that is you go to the main menu, go to set view, unit options, and then roll down to program card memory. When you say on and hit exit, everything that's on the monitor will be transferred to the program card automatically. Meaning that 3 o'clock in the morning, you have a problem, you go out there with a new monitor, you put the new monitor in, you make sure that the program card is on, the program card memory is on, and when you pull the program from the old monitor and put it in the new monitor, you don't have to do the wizard, it will automatically transmit that information to it. What you would see is when you put the new monitor in and pull the program card, it's going to tell you, okay, I see that you have your program memory is on, and we want to know, do you want to copy from program card, or do you want to copy the stuff that's on the monitor to the program card? In this case, you would say, I want to copy from the program card, and when you do that, it'll actually do it for you. One of the reasons why I like this screen too, and we were talking, remember I told you diagnostic? When you get this diagnostic, this is also telling you that there's not something wrong with, well, there's not something really wrong with the unit, but the memory, which is the memory card, there's something going on there. So as soon as you hit, I want to learn the program, it will automatically, this will go away and it will go normal. If there's a problem, you'll see this. If you see this, remember to hit the help screen, it'll tell you what's going on. And sorry, let me look, no I don't. On here, to give you an example, if you hit help here, it's going to tell you, did you turn on the program card? Because what it's telling you is on the card, there's some information there, and do you want to grab it? So when you see this, you might want to just go and hit help, and it'll tell you what you might want to do. So you can choose to turn it on and grab the information. Did that answer your question, Peter? Yes? Thanks. If you ever have any questions about that, I always say you can never go wrong playing. Play with the monitor. And what I mean by that, you don't do that at a live intersection out in the field. Set up a cabinet in your shop, or one of the other things I'm going to be sending you is I don't know if you guys have the, what I call the signal cabinet, but I have like a little, and I'll show you, here it comes. I got a document that shows you how you can create a power cord that you can actually use in the shop or in your one more time, in somewhere safe. So it could be in the shop. It could even be at home. I've seen people put them on their trucks. So what this is I show you how to wire a big connector or the B connector on a monitor to where you can power up a monitor. I'm going to blow this up. So when you're said and done, when you do the two little, make the two little plug, the port 1 plug and also the controller power, you can get your monitor to look like this, and then you can run through the menus and you can play with the monitor with the understanding is that you won't hurt anything. So I'll make sure that Mark gets this, and everyone that registered, and even if you didn't register, you guys know each other, you can ask me. One of the things that, let me look at the time, cool, we're right on time. I will send at the end of there, I'll give you my email and all that and say, Ben, send me all the stuff. Because I want to make sure you get two things. I want to make sure you get the video of the presentation, and I want to give you what I call my starter kit of just best practices, things going on. One of the things here, let me show you another thing that I find especially good for new technicians or new people is how to set up a program card. A lot of people get a little scared, not knowing what's going on. And then I always like to say best practices too. Sorry, I'm looking at my files and talking at the same time, which is not always good. Where is it at? Wiring diagram. I'm looking, or I know I have one here. Let's do this. Here it goes. So what I'm going to show you is a Excel spreadsheet. If I can get the thing to come in, get on my screen here. Come on, there. Come on. Why aren't you going up there? Let's do this. Sorry. Why are you doing it? Let's do this. Minimize. Okay. All right. For some reason, I can't get this to come up on the screen. There we go. Finally. So what this is on the program card. I set it up too small. Wow. So what I like to do is I send, this can come blank too, but I like to put my numbers on my phasing and how that's all wired up. And then I can sit there and say, this is, in this case, 2 and 6 are okay to go together. So you would put a jumper there or an X there, and then you would go through and say 2 and 5, 2 and 6. And this is where you can go ahead and program it and look at how you want to set up your program card. With the understanding is, one of the things I like about it is a checksum, is to have multiple people check your work. So if you ever are new or you're trying to set up a program card, it's a good way of having a copy of this in the cabinet or in file or a form or something that you can have when people, I'm not sure how you guys do your maintenance, or if you divide your cities up into, Bob has this area and John has this area and Ted has this area, or if you guys are pretty much sharing. But this just gives you a form to go ahead and fill out to say, okay, this is how we're setting up the program card. One of the things I've actually added to is a terminal wiring. So in this case, I'm working with an agency in Pasadena that's doing flashing yellow arrow, and they have, this is how they wired at the cabinet. So it's nice to be able to look to see how they wired the terminals of the cabinets. So they have that also. So this is a file that I'll send you, a blank file, so you guys can have that. in your toolbox. So if you ever need to set up a program card, you can. The LED guard we talked about. The clock is something I'd like to show because I'm not sure if you guys have any TS1 cabinets, but almost every agency has one or two. And it's nice to make sure that you set the time on the monitor, because as I said, on the TS1 cabinet, you have to physically set that. It isn't set by the controller. So the way to get to it is you would go menu, and then you would move down to where you say set time, click on set time, and then it goes per digit. So here it won't go 12, it'll go, if you want to make this 8, you have to make this 0 and this 8. And it always starts here. So it always starts with the first digit. So in this case, let's say if you want to go 1 o'clock, you would click here. I'm sorry, let's go 8 o'clock. When you put an 8 here, then you're going to have to move over and put a 0 here, and then so on. So it goes here, it does hour, minute, second, and then it goes to month, date, year. And at the end, you hit exit and you program it. If you don't, when it's shipped to you, you'll have Arizona time. So in your case, it'll be a 3-hour difference, I believe. Yeah, 2-hour difference right now. So, you know, and we do not do daylight savings time. You can also turn on and off the daylight savings time on the monitor. The monitor, I believe, comes with the daylight savings time off, because in Arizona, we don't know what that is, or we don't care what that is, should I say. I'm looking, I see no questions. I'm going to touch on the ECCOM software really quick, because I know your time is precious, and I just want to, I have a separate class on this, and I also have a video on this. The video, I believe, is like 5 or 10 minutes, and it will go through how the ECCOM software works. Not only, in this case, I just want to show you a couple of the screens that I find very important. Remember when I told you when you have a problem or you're doing your PMs, you go up, you hit status, and you look at all of your inputs? Well, if you bring your laptop, you plug it in and do ECCOM, when you hit the monitor status, it gives you it all in one shot. So in 1 second, you can see what all the voltages are coming out of all the load switches. You can see the voltage from the cabinet, the temperature, everything in one shot. When you first click on this, it's going to be a static screen. But when you hit update on, this will just keep on moving. So when the lights change red, yellow, green, you'll see it change red, yellow, green. What the understanding is, once you have the update on, it won't let you do anything else. So if you want to go and do something else, you have to turn it off. We actually have on the monitor memory that will keep the information. You can see that on the monitor itself by going view logs. So when you go view logs, what it'll do is it'll tell you how many previous fails you got, how many resets you got, and your AC. So the numbers will, if you clear your logs, if you at a typical intersection, you'll get like maybe 3 or 4 logs. If you go to that and it says 25, odds are when you do your ATSI test or something, you left it on or you didn't clear it, and it has all of those faults. But if you know that you cleared it and you walk up to an intersection and you have 25 faults, you have a lot of information you're going to have to go through to see why there's a problem there, because usually, as I said, that should be in the 3 to 10 range is what you're usually looking for there. Any questions on this? And as I said, I have, oh, there we go. Can we get the log from the controller? You cannot get the log from the controller through our software, but you can get the logs from the monitor from the software. If you want to grab the logs from the controller, you would have to get that using the controller manufacturers. Usually have a similar software that you should be able to grab the controller information. But in ours, you would use the software called ECCOM, and it looks like, and I'm going to do this in a second. I'm going to show you the icon. Yeah, minimizing, come on. Sorry, trying to drive and talk at the same time. The icon looks like, I thought it was on my screen. Let me give it to you here. There it is. So it looks like a traffic signal. And I'm going to open up the software so you can see it. There it is. Things I want to point out here since I've done this is you see how it's grayed out? It's not telling you that it's talking, okay? So a couple of things is down here, it was talking over IP. I have a monitor sitting in my desk that I'm now plugging in, and I'm going to go ahead, see, and it says, when I turned it or plugged it in, it recognized something. So what you can do is go configuration setup. In this case, it's connected by RJ45 plug or a computer jack. If it's a serial plug, which is a DB9 connector, you would click on this. If you're, in my case, we're doing networking. As I said, the video, and we can talk about this down the road, we do have a video on this software that I'll send you to on how to do this a little more in depth. But I'm going to go ahead and say okay. And let me look to see a couple of things. Make sure it's plugged in. You see lights. In this case, if you notice, it's still grayed out. So I'm going to have to come here, go here, setup. I'm going to go search. And what I'm expecting is you should see something come up in here for the search. And in this case, I think we're going to have a slight problem, which is good, because then what I mentioned is what I usually recommend is unplug the dongle or the cable and plug it back in. And I don't know if you heard the little ding, ding, ding. And now I'm going to try again, retry. I got it plugged in. I got everything going. Oh, there it is. So you see that it pops up with a MAC address. I always like to, it's still working because it has an hourglass. I want to make sure this is blue, that I clicked on it, and then I'm going to say okay. But if you ever want to change the IP, you can go configuration and you can do the changes here. I recommend if you guys want to set up your network with IP and all that, that you contact me or Everly and we talk about it so you can set it up, because if you don't know a lot about networking, you don't want to just start putting down IPs and doing stuff. So usually I recommend that we have a document explaining how the do's and don'ts, best practices to set up your network. Now what I'm going to do is hit test. And when I hit the test, I should see this is what we're hooked up to. I'm hooked up to a smart monitor. The type is a 1. Most people have type 1s. We do have some agencies that have their own unique type. The number that I usually ask is if I ask you what version you're running, it's the firmware version, and the most recent is 7.4. So you're going to go ahead and say okay, okay, and now everything you notice is no longer grayed out, it's darkened. So here's the status screen that I was talking about, and if you notice, I have my plug plugged in, so I have no inputs. So I'm going to go update, and now it's looking at everything. The only thing that's going to change is down here, because I have that dummy cable, just putting power to the intersection. But if you notice, I'm getting some interesting numbers here. When you're hooked up to an intersection, you'll see most of them, the reds will be on at 120, and then down here, you're going to see fluctuating between 2 to 10 volts. You're just going to see the leakage from that. If you notice, it's grayed out when I clicked on going live, so I can't do anything else. If I want to do something, I have to go off. And now I can look at stuff. This is a nut and screw, and this tells you the configuration. So this is showing you your configuration. One of the things I want to show you is if you do this and you want to run the wizard, you can run the wizard from here. Instead of on that teeny little screen, you can go ahead and run the wizard from the ECCOM software when you have it plugged in. The other thing is if you want to save this, you can actually go File and save your configuration of the intersection. So not only can you save it to the card, but you can save it to your computer. And someone asked, can you do this remotely? Yes, you can. Couple of ways that agencies do it is they set up where they take and create unique IPs for each monitor, and then you program the IP of the monitor, and then you can do that remotely. There's other agencies that go, we don't, when we have a problem, we'll plug in 1 or 2 intersections and do somewhat the same thing. So yes, we can do remote, Peter. If you're looking to do that, let's talk about that, because as I said, that's where you want to make sure that you set up your network correctly and you have your path. So yes, you can do that remotely. You can do it with the Ethernet version, or you can do it with the DB9 version monitor. If you have the DB9 version monitor, then you're going to need to get what they call a DigiCard or an Ethernet card to transfer from serial to Ethernet. But I can answer that and take care of that. So one of the things I like showing about this, though, is when you do your ATSI test, I always like to say, connect your monitor and grab the file. So here you would sit here and say, here's my configuration that's on the monitor out in the field. I'm going to save it to a file. So now I can go and save it to somewhere on my computer. And in this case, I usually come in here, I go test, I go Bob's my city. Or in this case, if you notice, I've been doing some work with Georgia. So here's the Georgia network, and I don't have any configurations from Georgia. That's interesting. What do I have? I just have videos, but I recommend that you go ahead and archive your configuration. I want to show you, not only does it do the unit, but also do the program card. In this case, the program card is blank. Give me 2 seconds. I'm going to put a program card in here that has some number, has some stuff done. So I was going to show you. So now I hit this, push and hold the reset on the monitor. I'm going to get out of this and then come back. And when I hit program card, you'll see there's my jumpers. So it shows your jumpers too. So if you're out in the field and you want to know, is my program card correct, you can bring up this software. What's nice about this is you can say, okay, in this case, channel 1, 5, and 6 is on. And let's say you go out there and they say there's a conflict, and you go, well, wait, I looked at my program card, I can see 5 and 6. If you connect the computer and look at it, you want to make sure, if I've seen it where 6 isn't on, meaning that you think there's a jumper, but the monitor doesn't see it. If this doesn't show 6 on, then you have a problem with either the jumper, the card, or you have a bad solder joint. So you want to go ahead to fix that, just redo the solder joint, or you might have to do a new card. But this is actually telling you exactly what's going out in the field. The other thing that's interesting or good about this is, if you notice, I have this monitor is in a 12-phase cabinet. So it even knows that this is a 12-phase cabinet. The software will let you, from here, I can tell that I have this set up as a TS1 cabinet on my test bench here. Here's your dual indications, your clearances, field checks, those are all there. And if you notice, they're grayed out because you can't change them. If it's not grayed out, you can change it. If it's grayed out, you can change it. One of the reasons why the field check is grayed out is because in a TS1 cabinet, the field check isn't important, or you can't see it. So it's not something you need to mess with. But if this was in a TS2 cabinet, which I will do right now, as I said, I've set up my test here, my tester in my office to go either TS1 or TS2. So I'm going to get out of this. I just told it it's a TS2 cabinet. I'm going to click on here, and when I come here, you're going to see, look, it ungrayed everything, and the field checks are now able to change. So if you want to change stuff, you can do it from the software, but you can ship it. Once you do here, you got to load it. So if you want to load it to the monitor, you can load it to the monitor by hitting there. You can load from the monitor, or you can save to the monitor. Any questions with that? And I know that was quick. That was more just to try to get you introduction to the software than anything else. But I want to show you that you have a lot of tools in your toolbox that you can actually do what you want. And someone asked, is there any way that you can change, and I'm not sure if this, let's see, is there any way to transfer data sets from the controller? Yeah, someone asked if there's any ways to take the controller. So what the way I see this is, you said you set up your controller and now you want the monitor to figure out what the controller is doing to put them on both the same page. No, that's the purpose of this is you program your controller, and then we want you, a human, to tell the monitor what you're doing. We don't want a controller or a controller manufacturer to set up the monitor, because when you set up a monitor, you need three things. You need to know the configuration of the intersection, you got to know the wiring of the cabinet, and then you got to know the unique things about a controller. So if you tried to get the information from the controller to the monitor, the controller can't see how you wired it, and it can't see the geometries of the intersection. So yes, you have to program your controller and your monitor separately, but on the same page, meaning make sure they both understand what's going on. And with that, let's see, I want to make sure I don't forget. Down here, I wanted to show you, there's my email, my direct phone number. So because I don't want to waste your guys' time, and I went over a little bit, about 15 minutes. Here's information. This is my direct number to the office. Now what I'm going to do is give you my direct number to my cell phone. And I actually had a call last night at 2 o'clock in the morning, and I answered it. So as I tell people, don't freak out if you go, wow, he answers his phone. Yeah, if I'm up, I will. So here we go. It is 480-524-7699. And I'll make sure on my paperwork that I'll give you all of that, but that's my cell number too. And I tell people, and I've had people do this too, as I said, call me in the middle of the night, but also text me. Sometimes, like right now, I'm doing a webinar and I have it set up to where, you know, the phones are answering and doing stuff. So what I ask people to do is send me a text, because if you send me a text, I have small little videos explaining what a conflict is or a dual indication. I have little 5-minute videos that I can send to you to help you figure out what's going on. Also, now that you guys done this webinar, I will also send you an email to one of the new web pages that we're coming up with that will have an archive. If I can get this going here, right, guys? Hold on. I have an archive of all the videos. So I'll give you an example. Here we go. Where's this at? Sorry. Here we go. No, wrong one. And of course, you can't see what I'm saying. And cool, you guys got my phone number and my information. What did I think? Come on, there. Here it is. So it's like a second here, but what I've done is a lot of I call it traffic tech talk. Say that 3 times fast. Or what I call the 333 or triple T. And what this is showing you, like this, I have a feature of how to set up a flashing yellow arrow mode H. I've talked to Mark, to Pete, to different guys. If you want me to do a special video just for you, like someone says, well, how do I save a key? I made a video, 5-minute video or 2-minute video on how to save a key. Monitor key setup. These are for the ATC cabinets and all that. I have those. Someone wanted to know how to do a Reno, so I gave them a Reno. Here's an H. So I have lots of videos that we are available that we can actually do. Let's see here, do the Eberly one too. So I also have what I call my general Eberly web page, which is all of the stuff that we do for not only traffic, but also parking and access. So see, I have you'll get this class here, the ECCOM class. I'll send you that. It is 17 minutes. I try to keep them between 10 to 15 minutes because I know most people don't have a lot of time. If you notice, here's my generic MMU2 class that is sort of like what we talked about today. So those will all be available in the next hour and a half. Usually about an hour after the class, it generates the video, and then I send out what I call my blanket stuff. So with that, I'm going to set up an unmute. So if anyone wants to ask a question, if they don't want to type it, they can raise your hand or just scream at me and say, hey, Ben, I have a question. Anybody?
I have Ben, it's Mark. Can you hear me?
Yes, I can.
Okay, now with the programming card, like as of yesterday, you helped us through setting up one, and we had to hit the reset button. Is that the case? Once you
Yes.
program the wizards to get it to the card to learn, you have to hit reset. Is that correct?
Yes, that is correct. And I'm glad you brought that up. You need to, on the unit itself, it will tell you, it'll say, oh man, let me bring it. It'll say that you need to do that. But anytime you do any changes, and what I mean by changes, if you pull a program card out and put another one in, that's a change. If you go through the menu and you change something on the menu, that's a change. You want to push, what I usually do is just push and hold the reset for 3 seconds, 1, 2, 3. That was a fast 3 seconds, but 1, 2, 3. And then the monitor will see that. The reason, even if you have some of the old dip switch settings, you want to get in the habit of always pushing and holding the reset for at least 2 to 3 seconds. What that does is it tells the processor and the monitor, hey, something has changed. Notify, see it, understand it, know it. If you don't do that and you just change it, your intersection may go on the flash, or it may not even come out of flash because it's confused. It's like, wait, you have something queued up here, but I don't know which is what. So what do you want? So pushing and holding the reset will actually tell the monitor, hey, we're starting fresh, everything's good, let's go. Does that make sense?
It does. It answers my question. I have one more question in regards to the power cords. Pete, our supplier for the EDIs, he's on the line here too as well. He's building us those power cords. But I seen in the picture that there was a little jumper on the port A.
Yes.
Is that necessary too?
Yes, and yes, it is somewhat. And as I said on this document, which I will make sure you guys get to, it explains to you that so I have some agencies that are only TS2 cabinets. So, or I'm sorry, TS1 cabinet. So they don't need the SDLC cable or, this jumper.
Right.
So,
yeah.
So what I also do too is, and I think I say in here, let's see, did I check that? How did you guys are still there, I hope.
Yeah.
I still hope you're there. You're there, aren't you? I just got to do it. You
Yeah.
guys are there, good. I have something, I think I talked to Peter about this too. There's the pin HH. If it's on logic ground, it thinks it's in a TS2 cabinet. If the HH is floating or not connected, it thinks it's in a TS1. So what I've been doing is I've been recommending that you put like on mine, I have a switch. I don't know if you guys can see me or not.
You were cutting in and out a little bit, but I think you're back.
Hold on.
No.
Looks like my camera is glitched. Let me see. I can't tell. Anyway, I put a toggle switch. I put a toggle switch from TS1 to TS2. You see that toggle switch? Yes?
Yes.
One of the things I've done is I've just taken a wire and just took the SDLC cable. Oh, we lost. Are you guys guys there?
We are, but you keep cutting in and out.
Are you sir? Something with the network. Don't do this to me. Jumper in the little jumper, and oh, you gotta be kidding me. I know I'm cutting in and out. The upside is the video is still running, so you'll get this. I'll talk to Peter about this, so he will get that for you also.
Excellent.
Okay.
Yes, so it could, because our desire is,
Okay,
as an agency here, is to get at a cabinet and use the, you know, the power supply in the cabinet to be on, and then, you know, make the changes and the adjustments and get the card sorted and get it ready to go, and then
right.
Power down, make the switch, and then put the, does that sound possible, what we're getting to?
Right. Well, and the other thing that I want to talk about too, and we didn't get into, is on the monitor, on the program card. A lot of times when the people do the program card, if they're not good with solder and all that, they'll put the jumper in, think they have a good solder joint. And I actually have a couple that people have sent me that they said, well, there's something wrong with the program card. It's a piece of crap. And I'll send you pictures. It's because they didn't know how to solder. So what's nice about it is the software I showed you, ECCOM, will show you what the monitor thinks going on, but you can also do the screen if you go menu, view, see program card, and you can go through and say, okay, this is what channel 1's got jumper. This is what channel 2's got jumper. This is what channel 3's got jumper. I'm writing down, I need to do a 5-minute video on that, because I've had people call me up and say, well, how can I check the program card? The intersection's running, but I don't want to pull the program card, because if you pull the program card, it goes in the flash. And I say, well, that's okay. You can do it from either ECCOM, which most people don't want to pull a laptop out, which is fine, but you can also do it from the monitor itself. And in the monitor, it'll show you exactly what's going on. You just have a smaller screen. The only reason why I like telling people to go ahead and push in the power or put in a laptop or connect a laptop is then you can always save the file too. So it's somewhat to cover your butt. So if like your supervisor says, hey, what's the program card up out there? You can hook up your laptop, take a picture, record it, or, you know, save the file, and then come back and say, yeah, on this date, on this time, I grabbed the information. So you have that. So it's a good way to cover yourself. One of the other things I'll be doing here in the next few weeks too is I'll be doing a class on best practices. And what that's going to be is like a 25-minute thing on for a technician, how and what you should do, you know. So a good thing is I always recommend having a log, a personal log. So you know when you come in on Monday, I'm working on Chandler in Arizona and I did this. And it's just nice to have a personal log. So if you ever get, you know, God forbid if something bad happens, it's always 6 to 8 months after you did whatever. And now you're trying to, in your memory, going, what's going on? And you don't have to have a detailed 100-page dissertation. It's just more of, okay, I was here on Monday on this date and I did this. It's just nice to get used to having a log. And then some agencies require a log in the cabinet, meaning that if you open the cabinet and do anything in the cabinet, you have to write down what you did. Yes, someone asked a question or asked something.